Hello, my name is Micah Scott, and today we're going to be finding the equations of a tangent plane and a normal line at the point -2, 1, -3 to the equation x squared over 4 plus y squared plus z squared over 9 equals 3. So the first step that we need to do is do partial derivatives to respect of each variable with this equation. So the first one we'll do it is x, respect of x, respect of y, and respect of z. And when we do the partial derivative of this equation for the respective of x, we have x over 2. For respective y, we have 2y. And respective z, we have 2z over 9. Next, we use the gradient. That's how we're going to, moving forward, when we find the equation of a tangent plane first, we need to find the gradient. And so the gradient says that for the function, we use the partial derivatives that we found as that point. So when we use the partial derivatives that we have and we plug them in, we have at the point 2, 1, 3, we have -1, 2, -2 over 3. So now that we found the gradient, now we can move forward to find the tangent plane. The equation for a tangent plane reads is this, that you have with respect of x minus x, the x of the original point, and then following for y at this point, plus z point. So we're going to use this to find our equation on a tangent plane, and we use the following information to fill it in, thus having down, we'll have -1 in parentheses x minus a -2 plus 2 in parentheses y minus 1 minus 2/3 minus 2/3 in parentheses z minus 3 equals 0. So having that, we'll just simplify and then find the equation. What I chose to do was just times this whole equation by 3 since we have a fraction. So basically this whole thing times 3. And so we have -3, yeah, negative 3, oh, yeah, negative 3x minus 6 plus 6y minus 6 minus 2z minus 6 equals 0. And we'll continue simplifying, and we will have negative 3x plus 6y minus 2z minus 18. I'll add 18 on both sides. That's having the equation at the tangent plane. 3x, negative 3x plus 6y minus 2z equals 18. So this is our tangent plane, or the equation at the tangent plane. Next, we will find the equations for the normal line. And to do so, the normal line equation reads as such that basically the information from the tangent plane will fill in having x0 over what we have for respective x equals y in its point to respective y, and same thing with z to respect of z. In simpler terms, we can have it like this, that our original point was negative 2, 1, 3, and the new point, well, using the gradient, we're going to use the gradient again. I'm just going to label it as A, B, and C. Equals negative 1, 2, negative 2 over 3. And so we can find the equations of the normal line as such, that x equals x0 to a t, y equals y0 to b times t, and z equals z0 to c of t, where t is a parameter. And so basically we will just fill this in, having x equal, thus having x equals negative 2, minus t, y equals 1 plus t, and z equals negative 3 minus 2/3 t. So to finish, the equation for the tangent plane was negative 3x plus 6y minus 6y minus 2z equals 18, and the equations for the normal line for x minus 2 minus t, y equals 1 plus t, and z equals negative 3 minus 2/3 t. And there we have found the necessary equations to find of the tangent plane and the normal line at the point of negative 2, 1, negative 3 to the equation x squared over 4 plus y squared plus z squared over 9 equals 3. And I bid you a good day.